Alright, so the short review. Alright, so we have a Little League baseball team, okay, and they're trying to hit off the tee. The league selected every last place team from each division to survey. What kind of sampling did they use? Now again, we talked about how we have to be flexible, and they're not always a black and white, but a big gray area in stats. Since this is every last place team, the first thing that comes to mind might be, to some of you, systematic. Every third team, every fifth team. Well, if each division has the same number of teams, and we said then every ninth team, the last place, that would be systematic. But let's say maybe some divisions have 9, some divisions have 10. Who knows? You could also say, since they're picking one team from each division, you might call that stratified, because they're broken up into divisions, groups, strata, levels, and you're picking from each one. So in this case, I would accept either one of those. Okay, grades in Honors Algebra 2 class. So these are the number of A's, B's, C's, D's, and F's. What's the probability? Well, remember, the first thing we always say to do is find out your total. Okay, so there is a total of 69 students. 18 plus 26 plus 16 plus 7 plus 2. Now, everything is going to come from that. So this is going to be 18 divided by 69. Now these boxes are pretty small, so I'm just going to go right to the probability. So I would divide 18 by 69, and that's 0.26, or 26%. 26 divided by 69 is going to be 0.38, or 38%. I would accept either way. 16 out of 69 is 0.23, 23%. 7 out of 69 is 0.1, or 10%. That's rounded, obviously. It's not 70, out of 70, but pretty darn close. And then 2 divided by 69 is 0.03, so 3%. So that's the breakdown in probability. Now the probability of A or B, that means you're looking at both of these groups combined, because you're just saying you can have A or B. So your chances increase of hitting an A or B. So basically you're just going to add 0.26 plus 0.38 and get 0.64, or a 64% chance of being an A or B. Oops, that got messed up. Okay, number 3. Now, we're going to put these in the calculator. So let's go through if you want to fast forward through this part because you know how to do this, that's fine. But we're going to put these in the calculator. So again, as a reminder, turn it on, go to Stat, Edit. Now if there's numbers in L1, go ahead and clear it out by hitting Clear, I don't know why I hit Enter, and coming back down. Let's see. Clear. Come back down. There we go. Sorry, buttons weren't working. Now I put my numbers in. So I have 19, 19, 3, 9, 15, 1, 7. I'm just double checking as I go. 20, 16. I'm looking at the numbers as I enter them also to make sure I didn't actually put them in wrong or hit the wrong key. 1, 19, 3, 1, 11, 18, 20, 6, and 6. Now, I'm not hitting enter yet, and notice, right here it says 21. If I count 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, there are 21 numbers in this batch of data. This tells me that this 6 is in the last batch. If I hit enter, Notice it says 22, but there's nothing in there, right? So that's okay. And you can always go back up and see that 6 is in the 21st spot. This tells me I have all my data, and this is what you should always do. Double check before you calculate. Okay? Now, at this point, we just hit the SAT button again, go over to calculate, and just hit enter. Now, make sure this matches the list you're on. It should on most calculators, but if you have a question, always during a test, ask. And then we just hit enter a bunch of times, and here's all of our data. Remember, this is our average, X with a bar over it. That's our mean. We don't need this or this. We can use either SX or OX. I'm just going to tell you, get in the habit, just put the SX, the first one you see. It doesn't really matter which one. I'll take either one. I always have my answer key prepared to take either one. And then number, we said that, 21. And then my 5-number summary, min, Q1, median, also Q2, and Q3, and the max. Okay? So, sample size is 21. The mean is 10.8. The standard deviation was either 7.3 or 7.13. I would accept either one. 5-number summary, right there. And the IQR, remember, the IQR is the range, the inner quartile range. So the regular range, which is not on here, but I'm going to add it, the regular range is 1 to 20. Okay, you can also put 19. I would accept either answer. But the IQR is 4 to 19. Or 15. Okay? Now, for the 5-number summary, I mean the Boston-Wishart chart, we put a line at each number we have represented, and then we make the 3 in the middle into a box. Then we add our whiskers, and there we go. Now, notice how the mean of 10.8 is clearly larger than the median. Okay? So we're not asked about it on this question. So on this one, since the mean, and again, this is not on your paper, but just bonus material, is greater than the median, it is skewed right. Okay, the mean is pulling to the right. All right, so number 4. And I have to give a shout out to Armani, with her permission, of course, legally. I actually forgot this part of the video earlier in the day, and she asked a question, and so now I'm fixing it. I would scratch out numbers like 141, 230 because they are distractors. It doesn't matter. It's just giving the word problem reality, but they do not need to be used in the calculations, and it could throw you off. So what we need here is the mean, 47 miles per hour. And then we need a standard deviation of 5.5. So, using z-scores, what's the z-score for this one right here? That's our actual score. So remember, very simple formula. Actual minus the mean divided by the standard deviation. And when you calculate that out, you're going to get negative 1.27. Now, this should make sense, because if you think about it real quick, if this right here is the mean of 47, and your mean is somewhere over here at 40, I mean your actual number is 40, that is less than 0. It's left of the mean, which means you should get a negative z-score. Something to think about before you can calculate. Now for part B, find the probability a car was going more than. It's underlined. As soon as you see more than, write that 1 minus. Okay? Because it's going to throw you off if you don't. Now, we do the same thing we did with the previous problem. We take the actual minus the mean, divide by standard deviation. And again, think about it. 45 is less than 47. So we're going to get a negative z-score here. Now, being that it's so close to 47, it's going to be pretty close to 0, and it's negative 0.36. Now we're going to look that number up on our table, And when we do, we get 0.3594. Now that's the area left of that z-score. We don't want that. So that's why we're going to write it over here and subtract it, which gives us 0.6408. And since it says probability, we're going to move that decimal to the right, 64.08%. All right. The first thing you should notice when you see number 5 is this, the p-hat. Once you see the p-hat, remember, we don't care about n greater than 30 because that's for a mean problem. We're not using the formula standard deviation divided by the square root of the number. That's for a mean. We're using the p formulas and the p conditions. So please make sure you use the appropriate formulas. Now, x and n, remember we talk about a test. Okay? So n is going to be the number of questions on your test. X is the grade you got. Okay, so if I got a 60 out of 75, okay, X is my score, and N is how many were on the test possible. And then, just like you would do with test grade, p-hat is your average, your score, your mean. You're going to do 60 divided by 75, which equals 0.8. All right. Now the conditions. Remember, you got to check the number times p-hat and times 1 minus p-hat. Remember, we talked about we go to the store, buy a candy bar for 80 cents, we pay with $1, we're going to get 20 cents back, 0.2. These both have to be bigger than 10. Okay, this is 60, which is greater than 10. And this is 15, which is greater than 10. We're good to go. 95%, we just look on our cheat sheet, in our notes, it's 1.96 for a z-score. Now the margin of error, this is where you got to be careful. We're going to use 1.96, our z-score, and this is right on your cheat sheet. But here's the big thing. I've seen a lot of people do this. Okay, and that's wrong. You're going to get the wrong answer if you do the square root of 0.8 times 0.2 and then divide by 75. It is the square root of the entire thing. This is on your cheat sheet. The formula is there. The square root is a big square root that covers the entire calculation. So you hit your square root key, then put 0.8 times 0.2 divided by 75 underneath it, like so. Let's try this again. Okay, so I would put in 1.96 square root, and I would just type in 0.8 times 0.2 divided by 75. Notice it's all underneath there. Okay, and I get 0.09. And I would write 0.09 here, because then over here, I don't have to write this entire mess. So the confidence interval, you just go back to your p-hat, 0.8, you put plus or minus, and then to save yourself time, you can just write 0.09 instead of writing 1.96 square root p-hat 1 minus p-hat over the n. And now you just add 0.09 and subtract 0.09. So that's going to give me 0.71 to 0.89. In other words, it's like 80 cents plus 9 cents and 80 cents minus 9 cents. And that's it. Now, of course, we need to have a mean problem to counter that. So there will be no p's down here. No p formulas. Okay, this is a simpler one. Our average, which is our mean, is right there. Okay, standard deviation is right here, 3.25, and we use 99% confidence interval. So conditions. I have 50 students, so 50 is greater than or equal to 30, good to go. Z-score for 99 is 2.58. The margin of error, you're going to write that 2.58 again. Remember, we're just going baby steps here. And then it's a simpler one. It's just this fraction. It's that 3.25 standard deviation divided by the square root of n, 50. Now again, even this is a lot to write, so once I calculate this, 1.19, I can just bring this over here. My confidence interval is that mean, 22.75, plus or minus the 1.19. And that's going to give me 21.56 up to 23.94. So again, it's like $22.75 minus $1.19 and $22.75 plus $1.19. And that's my range. Okay. Number 7. Start off, I would suggest, by putting your numbers in here. So this is 65. Well, I mean, not suggest, it's kind of required. It's got the boxes there for you. 73, then I'm just adding 8, adding 8, adding 8. Now I'm subtracting 8, 57, subtracting again, 49, subtracting again, 41. But I also like to put my numbers in here real quick. It doesn't take that long. You're just copying it from your cheat sheet. But it makes life easier. And this is 2.35, 2.35, 0.15, 0.15. It just makes it easier to answer all these. You know, if you really want to go to town on it, you know, you can put 68 here, you can put 90, 95 here if you want, and then, you know, 99.7. Even if you can combine it that way if you like. It says, we just label it, what percent of the words per minute are between 41 and 89? Well, 41 and 89, here's 41 right here. Here's 89, and that is from -3 to +3, so that's that 99.7 I just drew. That's almost the entire graph. Of course, I went too far with this. That'd be like, you know, right there. You know what I meant. What percent are below 49? Well, below 49 is right here, -2 going that direction. So that's 2.35 plus 0.15, which is 2.5%. Above 57. Well, there's two ways to do this. Above 57 starts here and goes that way. You can add 34, 34, 13.5, 2.35, and 15. Or think about it. That's supposed to be blue. That's 50% right there. Right? Just add 34 to that. So 50 plus 34, that's 84%. Now, using z-scores, is the z-score for a score of 71? Okay. Well, for this one, remember, 71 is going to be right here. Okay. In between 0 and 1. So our z-score, we should think about ahead of time. When we calculate this, our z-score should be a positive number between 0 and 1. So, remember, it's a very simple formula. It's on your cheat sheet. It's the actual minus the mean divided by the standard deviation. And here's why it's nice to forecast it. When you do this, you get 0.75. But let's say, just for the heck of it, it happens. You did 65 minus 71 divided by 8. Okay? You did it the wrong direction. And it happens. It's a very common mistake, no big deal. But if you did that, okay, then you would get the negative version, negative 0.75. Okay? But that's the other side of the graph. And that's why I'm saying, if you look at it and say, here's where I am clearly on the right side of the graph, so my answer should be positive. So that if you accidentally do this, when you see this negative, you go, wait a minute, that was a mistake. But if you don't think about it ahead of time, it's very easy to just get that number and move on. And then, now, the last thing, we're going to find the probability of less than 60. So, same thing. We're going to do 60 actual minus 65 divided by 8. That gives us negative 0.625. And that makes sense because 60 is right here below the mean on the left side of 0, so it should be negative. Now I look up 0.625, which I can't on my table. I need to round it, and I need to round it correctly. Okay? Remember, round it to the 100 spot, but round correctly. If you look up 6.2, it's going to give you the wrong area. So that's 0.2643. But since it said the word probability, you want to change this to 26.43%. And one more little bonus. Remember, if this would have said, instead of less than 60, if it would have said more than 60, as soon as you see more than or to the right or greater than, you're going to write 1 minus immediately. Then you put in the area 2643, and then you take your calculator and you do 1 minus 0.2643, and you get 0.7357 or 73.57%. Okay? So just think about it. Anytime it says to the right, you do 1 minus. And there you go. That's it.